Okay guys, so today we learned about the real number system, unions, and intersections. So the first part of this homework is finding the intersection. Remember, the intersection is a number that is in both sets. So it has to be in the first set and it has to be in the second set in order for it to be part of the intersection. So if we're looking at the two sets in number one, there's only two numbers that are in both the first and the second, and that's 2 and 4. So our intersection is 2, 4. In number 2, there's only one number that's in both of those sets, and that's 3, so the intersection is 3. In number 3, S-E-T and T-E-S are the same letters, so all of those, S-E and T, are all part of the intersection. R-E-A-L and L-E-A-R, same letters, so R, E, A, and L are all part of the intersection. 1, 3, 5, 7, and 2, 4, 6, 8, 10. There are no numbers that are in both of them, so this would be considered the empty set, or the null set. And then if you're trying to find the intersection with nothing, then you don't have an intersection. So again, we're on the empty set. The union is in a U, that's the symbol that we use for union. And on these, you are wanting everything from both sets, but you don't want to repeat a number. So if you have a number that's in both, then just write it one time. Otherwise, you write every single number that's in both the first set and the second set. So, I'm sorry, let me rephrase that. Not you write that is in both of them. You write one that is in the first one or the second one. If they're in both, then you don't write it twice, okay? So if you look at the first set, we're going to take 1, we're going to take 2. 2 is also in the second set, but I'm not going to write it again. We're going to take 3, we're going to take 4. 4 is also in the second set, but I don't have to write it again. And then we need to take 5, because 5 is in the second set. So we wanted all of the numbers from both of the sets. If you have any repeating, you don't have to write them twice. Number 8, we want 1 and 2. We want 3, don't write it twice. We want 7 and we want 8 in our union. Like you're putting them together. That's what union means. In number 9, we're going to want 1, 2, 3, 4, 5, 6, 7, 8, and 10, no 9. In number 10, we want 0, 1, 2, 3, 4, 5, and 6. In number 11, we want A, E, I, O, and U. But it's in union with an empty set, so just A, E, I, O, U. And in 12, we just want E, M, P, T, and Y. Okay, for number 13, you're classifying each of the numbers with which the subset belongs. We want you to use the correct symbols, so I'm going to put the symbols underneath each of these. Remember, we have the natural numbers, which is an N. Make sure you make it kind of highlighted there in the middle because it's got an extra little bar. We have the whole numbers, which is a W, and again, you want to make an extra little bar in the W. We have the integers, which is a Z, and there's an extra little bar in the middle, so just kind of highlight that part. We have the rational numbers, which is a Q, and you have, like, it's colored in on both sides here. And then we have the irrational numbers, which is an I, and it, again, is kind of thick there in the middle, okay? So, remember on your Venn diagram from notes, you kind of want to work your way from the center out, okay? So, -9 would, if you look at it, is going to be classified as an integer for sure. So it has the I, the Z, there, the Z, and it's also considered a rational number, so it's going to have the Q. Okay? -4/5. It's definitely just a rational because it doesn't fit into the other subsets. Q. 0. 0 is a whole number. Which means that if it's a whole number, then you definitely want to start walking out with your whole numbers. So if it's whole, it's also going to be an integer. Excuse me. And it's also going to be a rational. So a Q. So all three of those are going to work for 0. 0.25 is a rational number. Okay, remember rationals take on your fractions and your decimals and all of those things. Okay. Square root of 3. Square root of 3 is going to be an irrational number, an irrational. So this is going to be an I, and it's going to be kind of all by itself because irrationals are just kind of loners. 9.2 is going to be a rational number. It's a decimal. So it's not an integer, it's not a whole number, it's not a natural number, it's a rational. Square root of 100. Now square root of 100 becomes 10. 10 is, so you're looking at this as the answer 10. 10 is a natural number. It's part of our counting that you learn when you're a kid, okay? Which means that it's also going to be a whole number. And it's also going to be an integer. And it's also going to be a rational. Okay, so it fits all of those categories. And then negative 0.6 is just going to be a rational.